So this is the second video on confidence intervals, and the last video we went through with proportions, how you find the proportions with the critical values, calculating the margin of error, and then find the interval with the confidence statement. Okay, so we did the proportions, now we're on do means. Okay, so the pieces that you need are a little different. The basis is the same. Okay, the general formula, it's still the estimate plus or minus the margin of error. Now, how you get the margin of error, what your point estimate is, that's a little different. Okay, so confidence interval for a mean, the pieces you're gonna need this time. You need your sample mean. So we have our X bar, that's gonna be the point estimate, that's gonna be the midpoint. We have the critical value. Now this time we're using something called the t-distribution. And I do just want to point out, degrees of freedom is n minus 1. That's our sample size minus 1. And we're also going to need our standard deviation. Okay, now, if you have with the technology we have, a lot of this is either going to be given to you or you're going to be able to calculate it pretty quickly by using the functions on your calculator. Okay, so once you gather up those pieces, then you can go ahead and plug them into the formula just like we did for the proportions. Now, for the critical value, this is the table you're going to use. So it was important that I told you that it was n minus 1 was the degrees of freedom. This table can look a little overwhelming, but all you need is your vertical axis, and we're going to use the bottom line, the horizontal axis. It's called confidence level. Okay, we have our DF, degrees of freedom, is going up and down, confidence level going across the bottom. Okay, now the confidence level here is not 50, 60, 70%. Here's 95, 98, 99. So these are the values we're going to look for our confidence level. Degrees of freedom is going up and down the side. Okay, now it does show we have 1 all the way down to 30, and then it starts skipping. It goes 40, 50, 60, 80. You always want to round down, okay? And that means, what that does is it makes your critical value bigger, which is a more conservative interval. The bigger interval, the better chance that you're actually catching that parameter of interest. So you always round down. So if you're between 50 and 60, and you do n minus 1, you get 58. Well, normally that would round to 60. 58 is closer to 60. But you always want to round down, so we would go to 50, and that would be the degrees of freedom, and that would be the row that you would pick out for your critical value. So here we have the formula. Same concept. We have our point estimate, our statistic, which is X bar, plus minus our critical value. And again, from the central limit theorem, we should be able to see that this is standard deviation divided by square root of n. The back end again is our margin of error. Okay, and we're taking that margin of error, we're subtracting it, we're adding it, and we're getting our interval. So the same concept as before. Below is the average cost of t-shirts in the top clothing stores. Make a confidence interval that is 99.7% confident. Use the 68, 95, 99.7 rule. So first, I want to tell you the conditions are all satisfied. Just like before, I said we're just going to assume all conditions are satisfied, so we can go ahead and find our confidence interval, and we're going to assume this is a valid confidence interval. We are at 99.7% confident, and it's saying use 68, 95, 99.7 rule. So remember, that rule for your confidence interval, it's either 1, 2, or 3. So since it says 99.7%, our critical value is going to be 3. The other pieces you're going to need is your X bar and your standard deviation. Now, in this case, it's giving us a list of data here. Okay? And that list of data, you should be able to calculate average and standard deviation. If you have a graphing calculator, enter the list and use the one variable function on that. That will find one variable stat function will find those for you. Okay, so you might want to pause, do that now. If you want me just to find it for you quickly, the average would be 13.326. Standard deviation is 4.691. And we also need our n. In this case, our n is 9. So if we're taking all these pieces now and plugging it into our formula up here, just like before, Yes, you could plug it all in at one time, but I suggest doing it piece by piece. So if I write this out, we have 13.326 plus minus our 3 times 4.691 divided by square root of 9. So there is our formula with all the correct values plugged in. And just like before, I'm just going to take it bit by bit. I do my standard error first, just this little fraction here, and simplify it. So you end up with 13.326 plus minus 3 times 1.564. I'm going to now multiply the 3 times 1.564. And that should give you 4.692. And you're going to subtract to get your low end, add to get your upper end, and then that's going to be your confidence interval. From this sample, that confidence interval is telling us where the average population t-shirt cost is going to be. So doing that, we have 8.634 to 18.018. So this is where we believe the average for the population average t-shirt cost is going to be. Now, here's our interval. Writing it as a confidence statement is going to give this a little more meaning. As a confidence statement, that's not add in the parameter of interest, so we know what these numbers actually are. Correct calculation, but there, now we need to put some context to it. So make sure you double check your work here. I took it piece by piece. I'm going to erase all this. Okay. And just like before with the confidence statement, I'm 99.7% confident that the true average price for a t-shirt in the top clothing store is between $8.63 and $18.02. And again, this time, still telling you how confident I am. This time it's the average price. Okay, you need to make sure you tell it it's the statistic. Okay, what statistic it is. In this case, it was average, and we're looking at the price for t-shirts in the top clothing stores, and I rounded the money correctly. Okay, you talk about money in 2 decimal places, so I rounded to 2 decimal places, had my dollar signs so we can all see the correct unit. Okay, now that was an example with the 6895.9.7. I want to do one more example using the chart to find the critical value. Okay, so this time, 7 fossils were found of a miniature horse species. The summary data from the sample of 7 fossils is as follows. The average is 46.143 centimeters with a standard deviation of 1.190 centimeters. A normal horse height is normally distributed, so we can assume these heights are as well. Use this information to construct a 99% confidence interval. Okay? So this time it's giving us our summary stats. Okay, so without typing in our list into a calculator, it's already telling us our average of 46.143, standard deviation of 1.190. So I'm going to write that over here because I'm going to change screens a couple times. So we have our, I'm going to use the black to be able to see it a little better. Average is 46.143. 143. Standard deviation is 1.190, and it said we had 7 fossils. So again, we're assuming all conditions are satisfied, so this is a valid confidence interval. The other piece we need here is our critical value. So I'm going to call up the chart real quick. Let's just remember it's 99% and our N is 7. So when I go to the chart, okay, I'm going down the bottom to 99%. There's our confidence level. And degrees of freedom is N minus 1. So if we're looking at 7 minus 1 is 6. And you just go across, up from the 99%, 3.707 is our critical value here. 3.707. So there's the pieces we need. Average, standard deviation, our sample size, and our critical value. Okay? So again, confidence level across the bottom, degrees of freedom going up and down. Go over and pick out your critical value. Let me erase this. And let's just do the calculation one more time so you can have it in your notes. Okay, going back to our problem, we have 46.143 plus minus 3.707 times 1.190 divided by square root of 7. Doing the back fraction first, the standard error. We have 0.45. Doing some multiplying, 3.707 times 0.45. We end up with 46.143 plus minus 1.668. Subtract it, add it to get our interval, and we end up with 44.475 to 47.811. So there is our interval. So again, calculation, fraction first, multiply, subtract, and add to get the full interval. Okay, so let's take a look at the calculation, the procedure, and now think about what your confidence statement would be. Okay, I'm going to erase this so I can call it the confidence statement. I'm 99% confident that the true average height of a miniature horse is between 44.475 and 47.811 centimeters. Right. So there are two examples of finding a confidence interval for a mean. One using a 68959.7 rule. The other one is showing you how to use the chart. Now there are different charts out there. So the chart I gave you, the instructions I gave you were specific just for that chart.